Hello, my name is Todd Evans, and I am a Level 2 Product Support Engineer at Cole Morgan. And this video series is an introduction to the AKD Ethernet IP servo drive. Welcome to video 12 of the AKD Ethernet IP video series. This video will discuss the AKD jog add-on instruction in velocity versus position mode. We've already demonstrated using the AKD jog in the sample project, as seen below. In this section, we'll discuss the differences in how the AKD jog add-on instruction works depending on whether the drive operation mode is velocity or position. Regardless of operation mode, it is important to note that once the AKD jog add-on instruction starts executing, even if the rung logic and the AKD jog enable end becomes false, the axis will continue jogging until the drive is either disabled, a smooth stop has been commanded or executed, a hard stop has been commanded or executed, a soft or hard limit is triggered in that direction that it's jogging in, or the drive faults. This means that execution trigger on the AKD jog add-on instruction is a rising edge. However, be sure to use the sample projects method for triggering the AKD jog add-on instruction. In position mode, the jog is accomplished with motion task 0, where the AKD jog add-on instruction writes or loads the velocity XL decel from the AKD jog add-on instruction values in the ladder into motion task 0. Motion task 0 is set for a next task of 0, so the motion task loops upon itself during execution. Again, this is done by the triggering of the AKD jog add-on instruction. Since the AKD jog add-on instruction uses motion task 0 when the drive is in position mode, the drive must be homed before jogging is attempted. Execution of the AKD jog add-on instruction in this mode without homing first will result in an error with the ER bit on the add-on instruction's output being set. In velocity mode, it isn't required to home first before executing the AKD jog add-on instruction. More on this in a moment. Because we're talking about motion tasking, the drive command source must be service. Keep in mind the AKD move add-on instruction also writes to motion task 0 as well. In position mode, the top screenshot is an example of a successfully triggered AKD jog add-on instruction. You can note that the output done bit is turned on. The AKD jog add-on instruction populates motion task 0 with data and also executes or starts the motion task. As shown below, the time that the ladder logic above had triggered the AKD jog add-on instruction, the given motion task below was populated and started executing. Note a direction value of 1 forward in the add-on instruction will make the position field in motion task 0 positive, and a direction value of 0 reverse will make the position field in motion task 0 negative. In this way, the forward or reverse direction is accomplished in the jog. The magnitude of the position is automatically set by the AKD jog add-on instruction intrinsically and is not an entry of the AOI itself. In velocity mode, the jog is accomplished by writing to the velocity set point to vl.cmdu from the add-on instruction values in the ladder. In this mode, since motion task 0 is not used, the drive runs at the AKD jog add-on instruction velocity set point and isn't required to home first before executing the add-on instruction. The drive command source for the AKD jog add-on instruction in velocity mode must be service. The sign of the velocity set point in general is set by the direction value in the add-on instruction, where 0 is reverse or negative and 1 is forward or positive. Velocity mode best practices is to use the direction value for direction and put a positive value for the speed in the AKD jog block. It is worth noting that the speed entry will accept the assigned value. For example, if the direction is set to 0, which is reverse, and the speed is set to a negative value, negative x, where x is the target velocity, the effect is the direction of the jog will be positive because you're reversing but then also setting a negative value, so the two negatives cancel each other out. For this reason, using a positive target velocity for either direction and using the direction value is more intuitive and consistent. An example of the AKD jog executing in velocity mode. Down instruction was successfully triggered and done, and then the speed value in the entry of the add-on instruction is 655360, and when I query the vl.cmdu in terminal and workbench, you'll see that that is the set value for vl.cmdu. And if you look, you can look at the watch window, or in this case I looked at the velocity loop status tab, and you'll see that the velocity command is that value as well. It is up to the programmer to decide what operation mode they want to use. However, if the application requires positioning, most users will stay in position mode and home before triggering the AKD jog add-on instruction, because it will require less coordination than changing back and forth between velocity and position mode. In applications where the drive can't be home first on power up and jogging is required at that time, the drive will need to be switched to velocity mode, and then the AKD jog is used. Once jogging is complete in the setup or operation of the machine, the drive will then need to be switched back to position mode and the drive homed in order to make indexes or positioning moves. Next, I'm going to demonstrate the AKD jog add-on instruction in both modes of operation. First, we're going to demonstrate the AKD jog in position mode. So you'll notice in workbench and service position mode, the drive is already active or enabled, and I'm on the home screen, and at the moment the home, found, and done are not illuminated, so the drive has not been homed. If you look at the sample project on the rung with the jog forward AKD jog add-on instruction, we put a contact with the status of the home level here as an interlock, which indicates that when the sample project was developed, that the intent was that you would run it in service position mode. So before I can actually jog it, I need to be homed. So I'm gonna scroll to the AKD home add-on instruction. I'm going to toggle it, and it was successful. You can notice to the left that the found and done bits or indicator lamps are illuminated. Feedback position has been zeroed. So if I scroll to the rung with the AKD jog add-on instruction for forward, you'll see that the interlock is satisfied, and I can toggle to trigger and start the AKD jog add-on instruction. I can tell in the watch window of workbench that it is rotating. If I go to the motion task screen, you'll see that motion task 0 is running, that the velocity XL decel has been populated with the same values as in the add-on instruction that we triggered, and the position counts, the value is not as important as that the sign is positive, so we're jogging in the positive direction. If I stop jogging it, toggling this, you notice the motion task running becomes idle and it's stopped. That's because when I toggle that bit, the AKD stop smooth add-on instruction was executed. Okay, if I want to jog the axis reverse, I will toggle the bit. And if I look now, since the AKD jog reverse add-on instruction is populated with the same XLD cell but a different direction, the forward, if you recall, the direction was 1 and the reverse is 0, and therefore this running task, motion task 0, has the same velocity XL and decel values, and it's looping upon itself, but the value, the sign value of the position is negative. Hence we're going in the negative direction, as you can see here, of position and velocity feedback in the watch window. Stop it. Next, I'm going to demonstrate executing the AKD jog add-on instruction in velocity mode. So I'm going to change the drive alt mode from position to velocity. So service velocity. The drive is already enabled. And from the velocity loop screen, you'll notice that the velocity command is 0 currently. So if I toggle the jog axis forward in the ladder to start the execution of this add-on instruction, you'll notice that the velocity command is 65,536, which is the speed entry in the AKD jog add-on instruction here, and also that the direction value is 1, which is forward, so the velocity command is a positive value. If I go to the terminal and I type vl.cmdu, you'll see that that is the value that the AKD jog add-on instruction is writing to, and then that gets passed to the velocity command in the velocity loop. Now if I toggle the bit off, then the axis stops. This is because in the sample project, when that contact becomes false, it triggers the AKD smooth stop. The VL.CMDU is now set to 0. I could also go back to the velocity loop and see that the velocity command is set to 0 now. So now I'm going to go to jog reverse, toggle the jog axis reverse contact, starts the execution. You'll notice the values are the same as the forward, except the direction for the reverse is set to 0 versus 1 for forward. If you look over at the velocity command and velocity loop screen, you'll see that it's a negative 65,536. I go to terminal and type vl.cmdu. It's set to negative 65,536. I toggle the bit, and you'll recall that triggers the smooth stop below to stop, and the vl.cmdu is now set to 0, and the velocity command is 0 also on the velocity loop screen.